blah, blah.
It may be simple, but I don't know. I just looked at it on that blog.
Oh, all right. This does sound weird. So when a number, all right, so what can I write down? When a number, so this problem says, when a number is decreased by 20% of itself, the result is 20. Okay, let's break that down. When a number, what do I write? X. I don't know what the hell it is. When a number is decreased by minus 20% of itself. 0.2x. 20% of itself. I didn't need to write the 0, but it just did, so you can see the 20. This sounds a lot like that. Something's a 20% discount. You would write it like this. Whatever it was minus 20% of what it was, that's going to give me the sale price. So when something is decreased by 20% of it, the result is 20. And then you just solve it, yeah.
So when it says decrease, you do the subtraction?
Yes.
And then when it's less than, or if you like the problem.
Oh. Yeah, decreased is it's in the order in which it's stated.
Okay.
If I said if I have 15 apples and I decreased the number of apples I have by 7, that'd be 15 minus 7. If I said you have 15 apples and I have 7 less than you, I don't have 7 minus 15 apples. That's neat. I got like negative apples.
Yeah.
Right? Okay, good. And you're going to remember how to do this? What is 1x minus 0.20x? It's not negative anything. You got a whole x. And I'm only taking 20 away, 0.2 away, so you're left with 0.80. And again, you don't need the 0, but oh well. That's all right. And then, of course, you just divide. And again, to remind you, isn't there a 1 there? And can't I add as many zeros after it as I want to? Because math says, all right, whatever. $1 is the same thing as $1.00. Yeah. And 1.00 minus 0.20 is 0.80. $1 minus 20 cents, 80 cents, and then you just divide. I like it. Comes out to 25. $25 what? Did it say? No, it just said a number, so you're good. Don't worry about units on that one. It's like, well, it does sound weird. The number decreased by 20% of itself. You're like, what the hell?
I did it right the first time, but then I erased it because I thought it was
Too easy.
Yeah.
It's number 3. All right. Anything else from homework stuff? Yes.
Section 2.3 and 18.
18?
Yeah.
Yeah, 2, 3. All right. Before I do this for everybody, this feeling that you guys have not done this yet. Look at all those answers just floating around. Oh my gosh, where is it? Somewhere. I'll get this one. There. Oh, so many answers. So many answers. I can't do this. Oh, there it is. Screw it. I'm just going to write that there. I got this magic book. 8 decreased by 3 times. The sum of a number and 6. Now they tell you in the instructions that they want you to write this as an algebraic expression. This is an, what would you call this? I would say solve the equation, okay, because there's an equal sign. Here it says, is there going to be any equal sign? Do I see any words that mean equals? No. I don't see is, results in, none of that stuff. It's just going to be an expression. you're not going to be able to solve it. So 8 decreased by, all right? Automatically, I can write what already? 8 minus. 8 decreased by. Now, here's where things get weird. So here, I'm going to write this. 3 times something, right?
Yeah.
Yes.
Would it be 8 minus 3 and then parentheses?
Yes, so I got 3 times the sum of a number in 6. So what's the sum of a number in 6? X plus 6, I like it. Because what's 3 multiplying? Is 3 multiplying just the x? No. It says 3 times the sum. Oh shit. I need the sum first, and then I can multiply the whole thing by 3. And then you can simplify this, right? How would you simplify this? Distribute, and then get your like terms together, you're done. You can't solve it, there's no equation. I like it. Okay, anything else from homework? I'm very excited, so many questions. Oh, this is so good. Yes?
What do you mean we can't solve it? And you mean we can't find out x?
Yeah, there's no way to figure out what x is. There's no way to figure out what x
I mean
is.
3x plus 18.
Yeah, 8 minus 3x
18. Okay.
minus 18.
Yeah.
There's no equal sign to
8 minus 18
Yeah,
is...
there's no equal sign.
Yes, there's no total.
8 minus 18 is...
Figure out what x is.
Sure.
Minus 10.
That's it, you gotta stop there. There's no equals. There's nowhere to go. I love it when students start making everything in the universe equal to 0. That is so bleak. It's like very... 0. Everything's 0. But it doesn't say equals 0. It could be anything. I don't know what x is. If x is 1, this is negative 13. If x is negative 3, then this is negative 1. I mean, there's an infinite number of things this could be. Now, that sounds much, that sounds more hopeful instead of, right there. So, if it doesn't start as an equation, I can't get an answer for the variable. I like it. Now, real quick, I want you to really, really get this. If x were 1, then this would be what?
Negative 13.
Negative 13. You guys see that? Does everybody see that? If x were 1, this would be negative 3 minus 10 is negative 13. What if x were 2?
Negative 16.
Negative 6 minus 10, negative 16. Right? So now watch. If I had this equation to solve, we already know what the answer is going to be, but hopefully you guys remember what just happened a second ago. If I solve this equation, I get one, of course, because 1 is the value of x that makes this become negative 13. So when you set an algebraic expression equal to a number, you're finding that value of x that makes it become that number. When it's sitting here by itself, how many values could it have? An infinite number, because you can make x whatever you want it to be. Over there, no, this is saying I want the value that actually makes it come out to be this number, and that's why you get a specific answer most of the time. Right? Okay. Anything else from homework stuff? Oh, yes.
2.3 number 24.
Oh, okay. So this is semi-long, so just in case you don't have... Data display, 2,045% believes blah, blah, blah. For the period from 2000 through 2010, the percentage who believed decreased by about 1.7 each year. If this trend continues, by what year will only 11% of all American adults believe that most qualified students get to attend college? Now, I'll bet you anything. Oh, they don't say it. Okay, so we can make it whatever it was.
I like it.
So in 2000, we're at 45%. It's going down by 1.7% each year. And I want to know how long until it's all the way down to 11%. So tell me this. After 1 year, you do it, Jeff. Where would it be? It starts off at 45%. So after 1 year, if it's following this trend, where would it be? It's decreasing by 1.7% each year. So it starts at 45%. So after 1 year, it should be where? 43.3. So it would be, after 1 year, it would be 45% minus 1.7. After 2 years, it'll be 45% minus 2 1.7s. And that would equal whatever, 43, what did we say, 43.3. That would equal whatever. So now it's saying after how many years, so after X years, what would the equation look like? 45% minus 1 of these, 45% minus 2 of these, 45% minus X times this, and I want that to equal 11. So this is that thing I was showing you guys the last couple days, where you just give your brain actual numbers, because your brain goes, oh, I can latch on to that shit, and then you just follow what your brain does. And why did I know to put an X there? Because 1, there's a 1. 2, there's a 2. X, there's an X. I mean, the pattern's got to follow. However many years you want, I'm going to decrease it that many times. And then I force it to be 11, so I can solve for X. I can see, well, what would that have to be to make it become? Now be careful. If I got X equal to 12, what year is that? What year is it? We started off in what year?
2012.
So that would be 2012. I like it. So now just solve that equation. Right? Don't worry about making them decimals. It doesn't matter. They're all percentages, so it's all good. But this is the key step here, is just to give yourself a couple of specific numbers, and then just see what your brain does and put the variable in the right place. Who had their hand up? Okay.
So subtract 45 or
Yeah, subtract 45. Now what's a better way to write X times 1.7? Yeah, so it'll be 45 minus 1.7x. Subtract 45, divide by negative 1.7. They get a nice round number, believe it or not, they made this nice. Okay. Alright, let's do a little bit of new stuff. I start off nice. You guys remind me how to do this. How do I do this problem? How do I solve that? Cross multiply. I love it. Remember, cross multiplication is a shortcut that only works when I have fraction equals fraction. Students try to do it too many other places. No. So here I get 35x. Here I get. Now, what do you tell the person that does this? I always get somebody that does this. And then they're just like, okay. There you go. Or they set it equal to 0 or something crazy. Where the hell did that come from? What did they not do they were supposed to do? They pulled the 3 down, right? Instead of pulling the 11 up. You guys look at me like I'm crazy. Do you guys see what's it supposed to be? 35x equals 33. So what did they do? They put the 33 down instead of the 33 up. That's the mistake they made. And then they were like, what do I do from here? And I'm like, I don't know. Shit. Maybe go back and erase? So cross multiply. Bring that to that side. Bring that to that side. And please, dear God, never forget why that works, right? How would I kill this division by 5? Multiply by 5. It would cancel. So there, I would get 35x. How would I kill the 11? Multiply by 11. It would make 33. So that's just a shortcut of what I would do anyway. And now I'm one step away. Divide by 35. I like it. Not a major thing. Alright. What about this guy? Now see, this is funny. I am not saying I am Yoda, but I love that scene in the Star Wars movies where he's like, all right, Luke, you guys are, I'm a big geek, I don't care. So he's like, pick up your ship that landed in the swamp, and he's so big, and so he can't get, and Yoda's like, who cares how big it is, Chris? You do the same thing. He didn't sound like that. He sounded more like, lift the ship you will. But, what do I do here? Whatever that is, I multiply there. Whatever that is, I multiply there. So what do I do there? Same damn thing. Math doesn't give a shit that there's extra stuff in there. We do on the next step, but the first step is the same damn thing. I have a fraction equals a fraction. So I can do 2 times that equals 3 times that. And now I just solve it. So don't sit there looking at it and saying, man, that got ugly. I don't care how ugly it looks, it's still fraction equals fraction. You can still just cross multiply, right? That reminded me of my other favorite movie. Oh, you ugly face. You ugly face. Enemy Mine, Dennis Quaid. Look it up. It's good. Good movie, kids. Well, this is going to come out nice. I can't believe it.
If you just like skip the word, you see word.
Oh yeah, I know. I just want to make sure everybody saw where things came from. So you could just do 10x plus 4 equals 9x minus 3. Bam. Because that's what I'm going to get, right? 10x plus 4 equals 9x minus 3. This comes out nice. That is surprising. Subtract 9x. Subtract 4. X equals -7. This way.
Does it matter if you say like 1x or x?
Same thing, but I mean, you don't leave the 1 there. It's just understood to be there. Because you could, again, x, you could write that as 1x. You could write that as 1x to the first power. You can write that as 1x to the first power over 1. Oh my god. So we just say all those 1s are understood. I like it. Would I take points off if you did that? No, I would not. But just don't do it. A little note. And you're like, put as many notes as you want, Jeff. Just don't take any points off. All right. Let me see what you guys. Oh, you ready? This is the last problem for today. It's going to be nice and gross. I'm too excited for this. Sorry. Do it. I like it. So it's 2/3 over 4x plus 8. 5/2 over 9x minus 6. And again, I know that looks even worse now, but the first step doesn't care what it looks like. I don't know if you guys notice I picked the numbers to work really well with the fractions that are there. I know I'm a nice guy. I think this comes out nice too. No way. This comes out to a whole number. That's just lucky. Now let me show you. Here's how I would write this if I have any trouble with anything. And just remember, here's the idea. If I have something over something equals something over something, and that's that top minus the other bottom, and that bottom times the other top. It's what it is always. And then you just fill in what the hell these things are. So the first step is you just blindly go, okay, whatever that is, times that, equals whatever that is, times that. So the first step is completely mindless. Except a little bit of mindfulness going, oh yeah, I can do that here. Right, and then you do it. Now, if I were you, if I have any trouble with fractions, I would write this out. So I make myself a bunch of little problems. You see, I'm distributing it 2/3, but I'm not multiplying it yet. You don't have to do this all in your head. Go. So 5/2 times 4x plus 5/2 times 8. You see that I've distributed the 5/2, but I didn't multiply it yet? If you need to. If you don't, then don't. What happens here? Yeah, 3 goes into 9. 2 times 3x is 6x. 3 goes into 6. 2 times 2 is 4. 2 into 4 is twice. 5 times 2 is 10x. 2 goes into 8. 4 times 5 is 20. It does come out nice. It's crazy. Subtract 6x, you get 4x. Subtract 20, you get negative 24. Divide by 4, you get negative 6. That's awesome. I just came up with this shit out of nowhere, and it comes out to a nice whole number. You don't understand how unlikely that actually was. This is all from section 2.4, by the way. That's 2.4 is the one with ratios and proportions.
Really good.
Yes. You good? Yeah, I went that way. All right, that's plenty, guys. That's plenty. So we got that quiz Tuesday, and then we're going to finish out chapter 2. Christina.
ka natin masyado. Worth it. Basta na ito yan. Basta na ito. Mas money. Wow.